The dimensions of the ocean floor have mainly been determined through sonar. So as you travel down in depth, we really can't get there to be able to figure out everything ourselves or see it for ourselves. But by using sonar, we can then measure what this geography actually does look like. So starting with this first one, this is the continental shelf. So if you have to think from your time on a Jersey, Delaware Shore beach, this is where you spend most of your time on that continental shelf. Number 2 points to the continental slope. So this is going to be transition from the shelf to the seabed floor. 3, this is the continental rise. So it's going to have some sediment on it from this edge, and it does tend to have a much steeper angle to it. And then 5 down here, this is the oceanic basin, so that bottom. But again, the basin is going to be different depending on your different oceans. And then number 4, this is your oceanic ridge. So again, it's a young seabed that is going to actively be spreading these two sides of the ocean and the most volcanic activity. So the continental shelf mostly is going to be the rock granite. What else did I not go over? I think the oceanic basin is going to be made then of basalt. All right, so the different divisions of the oceans. You can really divide them into 3 different oceans, although there is the 2 additional oceans that then are incorporated into these parts. The first is the Atlantic. The Atlantic Ocean is going to have the shallowest, the flattest. It's not going to have trenches along those continental margins. It has these abysmal plains that are going to be those long stretches. Those abysmal plains then are going to have some fine sediment that have accumulated over time. And you're going to find that with your Atlantic Ocean. So it's pretty flat. There are no trenches, not many trenches in the Atlantic Ocean. But because it doesn't have them, it is then going to make it so that it is more prone to these coastal disasters. So you're going to have stronger storms come ashore, and that can actually bring devastation in terms of removing lots of sand from those coastal environments. Trenches tend to take a lot of that energy of those storms and act as a buffer for coastlines. The Pacific Ocean, the deepest, highest mountains, the largest sea that we have on our planet. It does have a lot of those trenches. So unlike the Atlantic Ocean, where it has that flat continental margin, this one is going to have a lot of trenches and ridges. It's not going to have a lot of those long, flat, abysmal plains. The ones that it does have are going to be much smaller in size in comparison to the Atlantic. The Indian Ocean is going to have characteristics that are kind of in between those 2 extremes. So it has some trenches, it has some longer abysmal plains with the Indian Ocean. And then the 2 other oceans, the Arctic Ocean, which we actually consider to be part of the Atlantic Ocean, so it's going to have similar characteristics to that, and the Antarctic Ocean, which is going to have similar characteristics to the Pacific Ocean. So if you were to look at them all on the map, you do have your Pacific Ocean, which has the largest area, extends from the west of North America into the East Asia area. Your Indian Ocean then is going to be between Africa, Asia, and Australia. And then the Atlantic is the one that you are probably most familiar with. That's going to be between North America and Europe, and South America and Africa. And then again, the Arctic is going to be the extension of the Atlantic, and the Antarctic is going to be the extension then of this Pacific Ocean. Now on to tides. Tides are going to be influenced by 2 forces. So the 2 forces that are going to influence when tides occur and how strong tides are the centrifugal force, which is the force of inertia. So if we were to think of the centrifugal force, as you are going around in a circle, you get sucked to the perpendicular angle. So I don't know if you've ever been on like one of those spinny rides and you kind of get sucked to the back of the wall. That is the centrifugal force. So that is absolutely going to be influencing tides because our planet is constantly spinning. So water is going to be forced in this perpendicular direction. And that's comparison to the centripetal force. That force then is one that's going to make things move on a straight line against the center of that force. And then gravity. Gravity is the other force. So gravity is a function of mass and distance. So on our planet, we have a certain gravitational pull, and that is also going to influence our tides. Now, the effect then of tides is going to be influenced by two large objects within our Milky Way galaxy. Number one is going to be the sun. The sun, just because of its size, if we think Earth rotates around the sun, is going to have an impact on our gravity that's going to influence the tides. But even more so, the moon is going to have a larger effect than the sun is on our tides. So depending upon the position of the moon is going to determine how our tides are on our planet. So although it has a much lower mass, it does have a much, much shorter distance to us. So it's going to have that greater gravitational pull on our tides. So the two main types of tides that we have are spring tides and neap tides. Spring tides are going to occur when we have a full moon or a new moon. Neap tides are going to occur when we have a first quarter moon or a last quarter moon. The spring tides are going to result in higher highs and lower lows because of the pull that you have the sun and the moon on each side, that it's going to be through gravity, it's going to pull the water more towards each of those. But if they're at an angle, a 90-degree angle instead of linear at 180 degrees, it's going to have a somewhat equal effect. So the deep tides are going to result in lower highs and higher lows because of the gravitational pull. The different patterns of tides. So you can have a diurnal, so di for two, so you're going to have one high tide and one low tide per day. And at the poles, you see this happen, as well as the Gulf of Mexico. So the emptying and filling rate is going to happen just once a day. The semi-diurnal tides, these are going to have two high tides, two low tides per day, and that might sound familiar to you because this is our tidal pattern. So most of the Atlantic coast is going to have a semi-diurnal tide. And then you can have a mixed tide system, so where you actually have three tides a day. So depending on how that forms, you can either have two high tides and one low tide, or one high tide and one high tide and two low tides. So this is going to be most of that Pacific coast that's going to have those mixed tides. So in semi-diurnal tide, you are going to have two high tides, two low tides a day. Mixed tide, you have three high tides, two low tides a day, or vice versa. And then the diurnal tides, you just have one high, one low tide per day. So I think that's the content that I wanted to cover today. Of course, if you have any questions, you can email, remind, message me. But I hope this was helpful, and I hope that you are all doing well. And until next time, I will see you later.